Let's look at another type of graph. Here we're asked to determine whether the relation defined by the graph below defines a function and give the domain and range. So first I want to ask you, is this a function? Is this graph, does it represent a function? If you said yes, that is correct, because recall the vertical line test. If you can sketch or imagine a vertical line going through your graph, and if it intersects in only one place, then yes, it is a function. Next, we want to find what is the domain of the function. So recall the domain of the function. We want to know how far this graph extends to the left and to the right. So one thing you have to remember here is the fact that this graph has arrows, or this parabola here has arrows on both ends. If we were to follow along this parabola with our pencil or this laser here, because we have an arrow here, we're coming from the left side, which is from infinity. Remember, arrows are infinity, so that's from negative infinity, and it will just continue forever and ever to positive infinity. So it's going to go forever and ever into the negatives and forever and ever into the positive. So we would say that the domain of this function is from negative infinity to positive infinity. And remember, all infinities are closed with the parentheses. Never use a bracket to close an infinity. Next, we want to find the range. Remember, range is how high or how low the graph extends. So first we want to find the lowest point on the graph. So the lowest point on the graph, as we can see here, is -3. As far as how high the graph goes up, again, because we have these two arrows here, this graph is going to shoot forever up into positive infinity. So starting at -3, and we're going to use a bracket when it start and stop at a point. And because it goes forever to infinity, we're going to close it with a parenthesis. So this is how we write it in interval notation form.